Hi, I'm Jan Ozer. I'm talking today with Dr. Hojat Yeganeh, who is a senior manager at IMAX Labs. He'll be discussing IMAX's AI-powered no reference live metric, the IMAX Viewer Score, or XVS, which is a component of IMAX Vision Science. Thanks for joining me, Hojat.
And I'm glad to be here.
Okay, let's start out by you telling us what IMAX does.
Well, IMAX is traditionally a theater company, so a company that licenses technology to theaters. So I'm pretty sure the people or your audiences are very familiar with IMAX theaters, but IMAX has another component, and that is like their cameras. Speaking of like cameras, you can think of Oppenheimer, and Christopher Nolan shot everything in film cameras. So film cameras, theaters or licenses to the theaters, and they started with documentaries, and then early 2000 they also started working on like a blockbuster movies, and that's the signature of IMAX.
Okay, so where does a metric fit into that?
Yeah, that's a very good question, Jan. So in 2022, IMAX bought SimWave. So we used to be SimWave, a startup company in Canada. The idea or the main intention was to bring IMAX differentiated experience in theaters to homes. So now the goal is to bring that IMAX experience to living rooms, like home theaters, and bring that awesome like a look and feel of IMAX content in homes.
How does the metric help them do that?
So the metric can give you like without measuring, so without knowing and understanding the artifacts and codecs and measuring all of those things that all of those the distortion that can happen in the stream world, we cannot understand or we cannot optimize the streams. We cannot bring that differentiated look and feel and experience into homes. So metric is an essential component of doing this task or achieving this goal.
Okay. So which IMAX product or service is the IMAX Viewer Score used in?
Typically two main products. One is called StreamAware, which is kind of a monitoring package which probes every component in the video delivery chain from the content creation all the way to the client, like players. And the other one is we call the StreamSmart, which is an optimization package. So now that we are able to measure, then we can optimize. So without being able to measure, we cannot optimize. So StreamAware is for monitoring, was basically a monitoring package, and the StreamSmart is the optimization package.
So it sounds like there's a high degree of integration between your product and the transcoders. How does that work?
Yeah, StreamSmart, which is the optimization package, is a data-driven or a machine learning approach. So like other machine learning approaches, we really need to go through one phase of learning and understanding the behavior of the codec or transcoder. And then once we understand the behavior, then we can easily optimize that. So that's why there is no issue in integration as far as we go through one round of training or learning.
Okay, and you're talking about a live service, so you're going to be actually adjusting some of the encoding parameters during the event itself. Which encoding parameters do you adjust?
There are few parameters that we can adjust when we are doing live streaming, like the bitrate values. That's the most important one. But the goal is that we adjust the bitrate values so that the quality of the content or the quality of the live streaming doesn't change. So it's like imperceptible, or the change that we introduce in the quality is imperceptible, or we call it just noticeable difference within a JND.
Okay, and that so you're reducing the bit rate as much as possible without causing a noticeable difference. Okay. What do users do with the StreamAware scores? That's a monitoring system, so that triggers an alert that says, hey, you've got a quality problem, or how are people using that?
Well, if you recall, I mentioned that the StreamAware package starts from the content creation all the way to the player side. So, and then you can think of many other like different use cases. When you think about content creation or like a contribution encoders or so, then source validation is a big thing. So they really wanted to know whether this source is qualified to start with, or it's a bad source. So you start with that, and then we have customers, they are in the VOD domain as well as in the live, but in VOD domain, they really wanted to know the distortion and the quality issues that they may have after transcoding or encoding, like banding, blockiness, and macro blocking that happens even in transmission, like a ghosting effect. And you name it. Like there are many different types of artifacts.
Okay. And that helps them identify and track those and potentially identify the causes.
Yeah, the other important thing that I need to point out here is the map, the quality map that we provide that localizes the distortion impairment, and people, they may understand, okay, where the banding exists, and then they can step one, like, or they can take one step towards mitigating banding, for example.
Okay. And are these products available as software as a service?
Both. Like our products can be installed on-prem, and also we can offer that as like a software as a service.
Okay. So looking at the metric itself, the IMAX Viewer Score, can you tell us exactly what it measures? What scores do you get out? How the scores map to subjective ratings?
The like IMAX XVS score ranges from 0 to 100. 100 means excellent, fidelity or similarity between the source and the output. We also offer no reference measurement, but with the same interpretation. 100 means excellent quality, and 0 means like a very poor, bad quality. What it measures all sort of distortion that can happen in the compression scenario or encoded transcoders, plus some other artifacts that may happen in the content creation, like a color distortion, skin tone deviation, or film grain loss or film grain distortion.
Okay. It sounds a lot like the SSIMPlus measurement.
Yes and no. Yes, in a sense that it is built upon SSIMPlus. But we continue innovating, and the current XVS score, IMAX XVS score, which is again like SSIMPlus, is a family of metrics. Now it's more inclusive, so there are more and more distortions that we can address today with IMAX XVS compared to SSIMPlus.
Okay. And one of the great things about SSIMPlus was its ability to measure quality on particular devices. Is that follow through with the XVS?
Yes, for sure. I would say that that's one of our signatures. So we really wanted to keep it, and that's a very useful feature. Customers, they love it.
One of the other great features about SSIMPlus was its ability to handle HDR, and in particular, compare HDR quality to non-HDR quality. Did that carry through to XVS?
Yep. Yeah, for sure. The current IMAX XVS handles HDR. In fact, with the close relationship with IMAX groups, we have access to much more, a wider, broader range of HDR content with many like content type and different aspect ratios and different characteristics that basically empower us to validate our metric more and more.
Okay, so let's take a closer look. At some point, you had to kind of reinvent SSIMPlus and go from non-AI to AI. What do you do when you make that transition? How do you start?
That's a very good question, Jan. The very first version of SSIMPlus that we built was completely knowledge-driven approach or knowledge-based algorithm. It was based on understanding human visual systems and modeling it in a mathematical way. So then, like when we hit some of those corner cases or some of the cases that like we couldn't address using like the old or the knowledge-based SSIMPlus, we decided to move from knowledge-based approaches to data-driven approaches. In that case, we didn't want just start blindly and build something on top of like a deep learning or machine learning or so. We still started from the knowledge-based approach or knowledge-driven SSIMPlus. And then we rewrote SSIMPlus using network language or deep neural network language. And then we made it differentiable because if we really wanted to train it, so we had to make it differentiable. So we made all of these steps. And then after that, we collected much more data and we asked subjects many questions about quality. And so what do you think of quality? And then we showed them also videos with a wide range of quality. And then we asked for mean opinion score. And then we trained the differentiable version of SSIMPlus using a subjective scores or a MOS.
How many videos are we talking and how many subjective scores?
There were more than 100,000 videos, and in terms of subjects, I don't remember. There were like I believe there were more than 100 subjects.
Okay, and when you say 100,000, is that full-length movies? Is that 20-second clips?
Mostly 10-second segments, yes, 10 seconds to 20 seconds.
Okay, and ranging in quality with different artifacts. One of the big issues I have with building encoding ladders is the whole understanding of whether people like lower resolution but better quality or higher resolution and a bit lower quality. How many resolutions did you test at to kind of get to the heart of that particular?
I think 5 to 6 different resolutions. So we started from UHD and then 1080, 720, 360, and 34 resolutions. Yeah.
Okay. So after all that work, what did you find the correlation was with this live no reference metric to actual subjective scores measured by MOS?
So the original SSIMPlus was like a 90% correlation. That was I'm talking about the knowledge-based approach. So when we moved to the data-driven approach, which is again, machine learning approach, then we got like I think if I'm not wrong, 4% more. So not, like 90 got up to 94%, which is huge. Like when you hit that saturation, like even 1% is a huge accomplishment. So 4% in that level is very is huge.
Okay, and is this continual? Will this go on so this score will be improving its correlation over time?
Well, there is a theoretical bound for sure. So like even if you think about subjective assessments, I'm not sure if you take the correlation of the subjective score versus mass, you may not achieve like 100% correlation, right? So there is a theoretical bound for that, and I don't think that we can like expect a metric to achieve like 100%. Maybe like even 94%, 95%, 96%. That would be like a theoretical bound. But I think for now, what we are more focusing on is not the numbers. So we are not focusing on the correlation anymore. What we care about mostly is like having a very solid metric with a minimum number of outliers, and we are working on the reliability of the metric, understanding how a better metric or how like a high correlation or more accuracy, or let's say high accuracy can be translated into more bandwidth savings. So the objective is now bandwidth savings.
So what have you found in terms of the accuracy of your metric and the accuracy of other metrics out there? And I'll go through them kind of in order. What about AVQT?
One of the biggest differentiated aspects between IMAX XVS and other metrics that are out there is the inclusiveness of the metric in terms of addressing many other distortion or artifacts that matters to content creators, like a skin tone deviation, color shift, like a banding, a film grain similarity. So these are types of distortion that content creators, they care about. Again, if you think about why IMAX bought SimWave and why IMAX cares about quality distortion, is because IMAX cares about creative intent. So we really need to address those types of artifacts and distortion that matters to content creators. We found out that most of the existing quality metrics, they mostly care about the compression artifacts, compression impairments. And the compression impairments are just one element that we need to consider in the video delivery pipeline. So there could be a lot of other distortion types that can happen in post-production, color grading, even in the delivery pipeline when it comes to the TVs or so, that these metrics, they don't care about.
Okay, so is that all of them, or is that, you mentioned AVQT because that's the one I brought up. What about VMAF?
Yeah, the same. Like if you think about VMAF, it's also a kind of learning-based approach. So of course, they train and they learn the metric. But when you look at what types of videos they train with, again, the most important, or they are most from the compression artifacts. So they mostly care about compression artifacts and blockiness and ghosting and all those stuff. Even the underlying metrics that they use, and they basically try to fuse these under multiple metrics. VMAF basically is a fusion metric. Those metrics are blind to many types of artifacts, like including banding, for example, or color distortion, skin tone deviation, film grain similarity, and to name a few.
Okay, so I mean, that makes perfect sense. If you don't train for a particular difference, whether it's banding or, as you talked, some of the color distortion that may occur during color grading, if you don't measure that, then your metric isn't going to comprehend it, and it's not going to be in the score. And certainly the older ones like PSNR and SSIM didn't think about any of that stuff. Interesting. So along that vein, if you were going to abstract what you learned about how humans perceive quality from what you learned from the metric, what do people like? What do people not like? I mean, is blockiness as bad as what people say? Is banding as bad as what some people say?
We try to basically look at the quality issues from a content creator point of view. So when we deal with content creators and we talk about like a distortion quality and their opinion, it's very tricky to get something right because they are very picky. So if you think about typical viewers, they get engaged into the content, and sometimes they forget about distortion that can happen in the content. Like banding is one example. If you ask the questions about the quality of this content which has banding, most of the people, they don't notice banding at the background. They just focus on the foreground with the character and like whatever is going in the foreground. But when you talk to content creators, they care about every piece of that content, every pixel in the content. So that's why I'm saying that it's very tricky when you work with when we work with content creators. But like if I wanted to talk about the typical viewers, yes, like compression artifacts is the most annoying thing, like a blockiness, pixelation. You may also hear something about pixelation or blockiness as some kind of words that people use to describe that. Well, I don't like the quality of this video, even though sometimes it's not only pixelation, it could be macro blocking because of transmission error, or it could be like a huge compression artifacts on a smooth gradient part of the content. But again, there are two different perspectives. We have to be very careful and meticulously care about every distortion that can happen in the content. But if we talk about typical viewers, they mostly care about compression artifacts.
Okay. Listen, Hojat, thanks for taking the time today. This has been very, very informative and very useful.
It was my pleasure, Jan.